So finally, we received our hardware kit from NXP Semiconductors. Last month, me along with my two friends participated in a robotics challenge AIM organized by NXP. It's a self-driving car design challenge which is divided into two stages. The first stage was simulation based, in which we were provided with the obstacle loaded track, and participants are supposed to write their own algorithm to complete a single lap of track in minimum time. Based upon the performance evaluation, they selected 16 teams out of 650 plus teams across India for the grand finale, which is second stage of the challenge. So now we have to port our algorithm to the actual self-driving car that we receive. Talking about hardware, it's an industrial grade hardware which is designed for industrial use cases, because the main goal of this challenge is to get the participants an idea of advanced industrial hardware before joining any industry itself. It's very costly as well. You can see the amount mentioned here is 1,77,000 rupees, which is more than 2,000 US dollar, I guess. I received this few days back and I was so excited. I couldn't resist myself to open it up. So here I am doing a quick re-unboxing. In the box, we got some sort of component list, some user manuals, and three boxes which have all the electronics and parts of the car. We will see them one by one. So starting from the very first box, it contains a CAN hub expansion board. I'm keeping the main development board side. I will come to this later. One CAN hub K3 board, few power cables along with the LiPo battery tester, and few cables for connecting sensors, one 3S LiPo battery charger, and one 3S 11.1 volt LiPo battery as well. Few fancy screws, I don't know where to use them. I have to read the manual, I guess. And here we got the secondary eyes of the robot, that is LiDAR. It's a small LiDAR in size, but its range is 25 meter, which I suppose quite good. Next, and one of the most important thing I got in the box is this CAN hub K3 board, along with the casing and few other electronics, which is used to debug the board via UART protocol. It's a kind of communication gateway, so all the sensors, electronic speed controllers, actuators are directly connected to this board. We are using this as a motor controller, you can say, but its uses are not restricted to a smart vehicle only, because it comes with many smart functionalities as well. You can see a lot of ports for connecting the external peripherals as well. In the next box, we have extension for CAN hub. It provides IMU functionality as well. It has an SD card port, so you can do image processing from CAN hub at some extent. But in our case, we are using a different board for all that. It has extra I2C SPI ports and GPS port as well. But for our case, it's an indoor autonomous vehicle, so we are not utilizing this capability right now. Now it's done for the second box. I found exactly what I was desperately looking for: the powerful brain of this kit, the NavQ Plus board. It is also manufactured by NXP itself. I will come to this later. Apart from this, we got a few parts of the car, some more electronics. This is also for debugging and image flashing to the board. Now it's time to unbox the beast, which is NavQ Plus board. Some block diagram, which is not easy to understand, keeping them aside. USB to serial cable to access the nav keyboard via USB port, and industrial Ethernet connector cable, some screws for camera mounting, some kind of component list. Now this is the actual NavQ Plus board, along with the camera for image processing, machine learning and all, because it's an AI/ML companion computer for mobile robotics. It comes with ARM Cortex A53 processor for machine learning, vision, multimedia, and industrial IoT. Now, at this point, you might be questioning, even Raspberry Pi 4 comes with ARM Cortex A72, then how NavQ Plus board is more suitable? Because it comes with NPU accelerator, NPU stands for Neural Processing Unit, which is a type of processor specifically designed to accelerate the machine learning tasks, and it's capable of performing 2.3 trillion operations per second. Apart from this, NAPU board comes with a special Ubuntu OS, which has packages only relevant to robotics like ROS, OpenCV, etc. So this decreases the CPU load little bit. It also supports Yocto Linux, so you can create your own custom flavor of Linux, which will be tailored to your needs only. Last item from the kit is car itself. Here you can see a prototype only sticker. I guess because actual selling unit is different maybe. Here you can see transmitter frequency written 2.4 gigahertz because it's a remote control vehicle, but we are not provided with any sort of transmitter. Our job is to use provided electronics to make it a smart self-driven car. In the box, we got the car chassis. Apart from that, there are some screwdrivers, screws, zip ties, few connecting cables, some more screws, can have programmer and debugger. Here we got the receiver, but I don't think so we will be using it anywhere. Now let's take a closer look at the chassis. It's a 4-wheel differential drive with a steering control mechanism. 4 sockets are also given along with the head and tail lights. At the base, DC gear motor is placed to drive the wheels just like actual car. Here one power distribution board is mounted to power all other electronics. So that was complete unboxing of the kit. In future videos I will assemble it. You might see this cool robot in action, so don't forget to like the video and subscribe to my channel. Also, I post robotics and electronics based stuff on my Instagram, so don't forget to check out that as well. See you in the next video.